So this is AMU5L3, and we're going to talk about circular motion. So that's motion in a circle. Now we are going to be using some of the formulas that we've picked up in the first two lessons, mainly changing degrees to radians, which if you remember, you multiply times pi over 180. And then the formula for arc length, which was where you multiplied the radius times theta, but theta had to be in radians. So to get that, you were using this formula. Now, we're going to look at two kinds. There's two kinds of circular motion. There's linear speed and angular speed. So before we get into the formula, let me show you what the difference is. Here's a circle, and this pink bar is the radius. And these two flags are different points on the radius. Now, when you're talking about linear speed, that's going to be the arc length. So if I went from 0 degrees to 90 degrees, you can see that the blue tab up here would have traveled a farther distance. You know, it's like if you're running on the track and you don't want to be the outside person, you want to be the inside person because you don't have quite as far to go. So the pink flag doesn't go as far. Now, if we're talking about the angular speed, that is the rate of change of the angle itself. So when I do the same thing, if I go from 0 degrees to 90 degrees, see both tabs, no matter where they are on the radius, they travel the same amount of degrees. So when you have linear speed, it's going to matter how long your radius is. But if you have angular speed, it's not going to matter. So let's look at our formulas. The first formula for linear speed is notated with a V for velocity. And the formula is just S divided by T. All right, S is that arc length that we learned in the last section. So sometimes they may just tell you what the arc length is. Sometimes they may tell you that they may give you the degrees in radians already, so you don't have to convert. So your worst case scenario is when they just give it to you in degrees, because then you're going to have to convert it plus put it in here and then divide it by T stands for time. All right, your formula for angular speed has this weird looking W. And that formula is just the degree or the radians. In other words, the central angle in radians divided by time. Okay? So let's get some problems and look at how to apply these. Okay, the first two problems use the same scenario. It's just we're going to find linear speed and then angular speed. So there's a bicycle tire that has a radius of 14 inches and it is spinning at a rate of 125 revs per minute. All right, so let's get our linear formula. V is equal to S over T. Now S is my arc length. So how can I convert this to arc length? Well, your formula for arc length is the radius, which we have, so that's 14. And let me come out to the side so I don't run out of room. So S is equal to your radius, which is 14, times your degree measure in radians. Well, if it's spinning 125 revs per minute, how much is one revolution? 2 pi, because we're using radians. If we use 360 degrees for a revolution, then we're just going to have to convert it right back. So let's go ahead and use 2 pi. So we're going to multiply 2 pi times how many times it's revolving per minute. So that's 125. Okay, so we have the radius times the degree measure of one whole circle, or rather the radians of a whole circle, times how many times it is revving per minute. So when you do the math on all that, that is going to get you 3,500 pi inches. All right, so, and that's how much it's going every minute. So here is inches per minute. And we want to change this to decimal. So all you're going to do is 3,500 times pi and hit your enter button. And that is going to change it to 10,995.6 inches per minute. Okay, now let's look at the angular speed. Here's our formula. So we've got angular speed is equal to theta in radians over time. Okay, it's the same situation. So what was our theta? Well, the degree measure was 2 pi times however many times it went around, 125, and this is every minute. So all you're going to do this time is 2 pi times 125, which will give you 250 pi over 1. So you put that in the calculator, and that will simplify down to 785.4 radians per minute. Okay, for numbers 3 and 4, we have the same scenario again, and this time it's a CD that has a diameter of 120 millimeters, and it is rotating at a rate of 45 revolutions per minute. So we want to find the linear speed and the angular speed. All right, so for linear speed, I need my S, which is R times theta in radians. So S equals, how many revolutions have I got? 45. Now, what is my degree measure? Well, it's going around 45 times, but how much is one time? Well, one time is, okay, on number 3 and 4, we have the same scenario again, and we're going to find linear speed for number 3 and angular speed for number 4. So the scenario is that there's a CD with a diameter of 120 millimeters, and it is revolving, or it's rotating around at 45 revs per minute. So first, to find linear speed, I need to find S. All right, what is S? Well, S is equal to the radius times theta in degrees. What's the radius? Well, if this is your diameter, your radius is 60. It's half of that. Now, your theta is going to be 45 times a whole circle, because it's going around 45 times. And remember, we could use 360 here, but that's going to give us an answer in degrees, and then we would have to convert it. If we just go ahead and use 2 pi, then it's already in radians, and we don't have to convert. So S is equal to 5,400 pi, and this is in millimeters per minute. Okay, so now we're ready to put it here. All you're doing, once you find S goes over time, and this time is for 1 minute. So we don't really have to do anything. Now we are going to convert this to a decimal. So when you put 5,400 pi into your calculator, that is going to give you, and we need the approximately sign, 16,964.6 millimeters per minute. Okay, so for number 4, what we need to find the angular speed is we need theta. All right, how many degrees total was it? Well, we already figured that over here. Actually, it's 45 revs per minute of a 2 pi circle. So when you multiply those together, you get 90 pi. Since it's only going for 1 minute, that's divided by 1. So if you put this in the calculator, that's going to give you a decimal of 282.7, and this is in radians per minute. Okay, for number 5, you have a 16-inch diameter tire on a car that's rolling at 500 revolutions per minute. Now we have to read carefully because it said find the linear speed in miles per hour. So notice the information we're given is in inches and minutes. So we are going to have to convert our final answer to get that to miles per hour. But anyway, we're going to start with our linear speed formula, which is V is equal to S over T, and the T is just going to be 1. So how do we find S? Well, first, instead of a diameter, I need a radius. So if my diameter is 16, my radius is 8, right? So to fill into my formula for S is equal to the radius, which is 8, times theta. All right, if it's going 500 revs per minute, and how much is one revolution in radians? 2 pi, okay? So that's the basis, and when we run all that through the calculator, we're going to get 8,000 pi, and this is inches per minute. And you can put it over 1 minute if you like to look at it that way. So there's where we're starting. Now, that's actually the answer. It's just not in the right format. So how do you convert 8,000 pi inches per minute to miles per hour? Well, first let's just convert it to an hour. How many minutes are in 1 hour? 60. So if we multiply this times 60, that's going to change it to an hour. And when you multiply 8,000 times 60, that is going to get you 480,000. And so that's every hour. Okay, now this is inches. So to go from inches to miles, we're going to be dividing. So first of all, if I divide these inches by 12, then that gets it into feet. So 48,000 divided by 12 is, 480,000 divided by 12 is 40,000. So now we have it in feet per hour. One last conversion. How many feet are in a mile? 5,280. So we're going to see how many of those are in 40,000. So divide 40,000, and I'll write it over here. We're going to divide that by 5,280, and that's a calculator job. But when you divide it, you're going to get 23.8, and this is now in miles per hour. So the actual trig part of it wasn't hard, but converting from inches per minute to miles per hour was a little tricky. Okay, for number 6, our scenario is a circular saw blade, and it has a diameter of 9 inches, and it's running at 2,800 revs per minute, revolutions per minute. Now we want to find the angular speed on this one. So actually, if you remember, for angular speed, the distance from the middle doesn't count. It doesn't affect anything. So we're actually not even going to need the diameter or the radius. All right, what we do need is theta. And that is the number of revolutions times one circle. And since we want this in radians, we're going to do 2,800 times 2 pi. Now your time is just going to be 1 minute. All right, when you multiply 2,800 times 2 pi, you're going to get 5,600 pi, and that is radians per minute. Now the question asks you how many per second. So if it's doing 5,600 pi per minute, well, how many seconds are in a minute? 60. So all we're going to do is take 5,600 pi, and we're going to divide that by 60, and that's a job for the calculator. When you divide that out, you will get 293.2 radians, and now this is per second. Okay, for number 7, we have a windmill that has blades that are 14 feet long, and it is moving at 5 revolutions per second. And we want to find the answer in miles per hour. So once we find the answer, that's going to be in feet per second. We're going to have to convert that to miles per hour, so keep that in mind. All right, we are looking for linear speed, so that is S over T. And what is S? Well, it's your radius, which is 14 feet, times the degree measure. Well, since we're going around 5 times, that's 5 times the radian measure of a circle, which is 2 pi. So once you multiply 14 times 5 times 2 pi, you're going to get 140 pi feet. So this is the distance, and this is per second, per 1 second. So now we need to convert this to miles per hour. Well, since this is per second, let's see how many feet it goes in an hour. So from second to minute, I would multiply times 60. And then from minute to hour, I would multiply times 60 again. So what that's going to get me is 504,000 pi. 504,000 times pi. And this is per hour now, but it is still feet. Okay, now how do you convert feet to miles? Well, now you divide by however many feet there are in a mile. So we're going to take this number and we're going to divide it by 5,280. And when you put that in your calculator, that's going to tell you approximately 299.9, and this just changed it to miles per hour. Next, we're going to look at how to use angular speed to find linear speed. And this is just going to be a series of substitutions across here on your guided notes. All right, the formula for V was S over T. And then we could substitute this in for S. So that would give us R theta over T. Okay? If we separated this so that we had R times theta over T, like this, what is theta over T? Well, we would come back up here and go backwards. That's actually angular speed. So you can multiply your radius times an angular speed and get your linear speed. Okay? It's going to be a little bit of a shortcut, and you don't have to go through all this. This was a proof to show you that your linear speed is equal to the radius times your angular speed. Okay, in problem number 8, we have a ceiling fan with 25-inch blades. So our radius is 25, and it is going around at 40 revolutions per minute, and we want to find the answer in feet per second. So we are given, this is inches, and this is in minutes, so we are going to have to convert when we get through. So let's use our new-ish formula. We need the radius, which we already have. We need to find angular speed, which is theta over T. So to find that, all right, what do we have to find the degree? 2 pi is 1 whole round. We're going around 40 times. So what is that going to give us? 80 pi. Now we can multiply 80 pi times the radius, which is 25 times 80 pi. So that's going to give us 2,000 pi. And our units here, that's going to be inches per minute. Okay, so let's go ahead and convert. What all do I need to do to convert this from inches to, all right, to go from inches to feet? What am I going to do? I'm going to divide by 12. And then to go from minutes to seconds, what am I going to do? I'm going to divide by 60. So you can do all that at once. When you put that in your calculator, that's going to give you 8.7, and you went to feet per second. Okay, for number 8, we have Ryan riding his bicycle, and the wheels are 28 inches in diameter. The wheels are rotating 130 RPMs, which is revolutions per minute, and we want to find miles per hour. So we've got inches and minutes that we're going to have to change to miles per hour at the end, but let's find our answer first. All right, we have a diameter, so I'm going to go ahead and write under here that 14 inches would be our radius. We want half of that. So we are going to use our new formula. We already have the radius, so let's see if we can find the angular speed. All right, W is equal to the theta, which is how many revs does it go? 130 times what? 2 pi. So that is going to give us 130 times 2 pi is 260 pi, and this is radians per minute. Okay, now let's come over here and let's do V equals. All right, V is equal to my radius, which is 14, times the angular speed, which I just found. So that is 260 pi. And when you multiply those together, that's going to give you 3640 pi. And remember, we just found this in inches per minute. So let's talk about the conversion. Now, what would you do if it's going 3640 in inches? What would you do to change that? Let's change time first. If it's going 3640 in a minute, and we want to change it to hours, what do you multiply the minutes by to find out how many times per hour? Well, that's going to be times 60. And then we're going to go to inches. Let's change that. What would you do to convert from inches to feet? Well, you're going to divide by 12. And then what would you do to convert from feet to miles? Well, you're going to divide by 5,280. Now, when you do 3640 pi times 60, divide by 12, divide by 5280, that is going to get you 10.8 miles per hour. Okay? Good job.